Hello everyone. So welcome back to the channel. I hope you guys are doing pretty well. So let's see today's daily challenge on Leetcode and we will try to solve this together. So today's challenge is a very easy problem, simple to think as well as easy to implement. So let's see the problem statement. Largest submatrix with rearrangement. You are given a binary matrix of size m cross n. You are allowed to rearrange the columns of the matrix in any order. Return the area of the largest submatrix within the matrix where every element of the submatrix is 1 after reordering the columns optimally. Okay. So as you see in this example, if you reorder this column somehow, you can find the uh, largest rectangle which of ones containing only ones, right? So largest area of ones, and it should be a rectangle. Okay, so return the area of the largest submatrix. It means the largest rectangle only within the matrix where every element of the submatrix is 1 after rendering the columns optimally. Okay, so yeah, that is all with this problem statement. And yeah, I hope you will try this problem on your own first and then only continue watching the video. So you see, you are given a binary matrix, okay, which looks something like this, and it has some zeros and ones, and you need to arrange the columns optimally, right? So you can think it something like, let's say we have uh, this consists of one. We have more ones here. Let's say this is one, this is another one, and we have, let's say, this many ones here, and remaining are zero. Okay. Uh, yeah. So remaining are zero, and let's say we also have another row. Okay, something like this. So what can you say? What is the, how can you arrange these columns? Okay, you are free to arrange the columns, and how will you exactly try to arrange the columns where uh, you can get the largest rectangle? Okay, so by doing by looking at this matrix only, it is very obvious to think that you want to take some row as the base. Okay, let's say take this row as the base. Okay, or let's say in this case take this row as the base, and you, for every row, by taking every row as the base, you want to rearrange them, and you want to see what is the largest possible thing. Okay, like what is the largest possible rectangle you can inscribe in this. Okay, so yeah, by doing this you want to check that, but you see, how do you get them? How do you exactly get them? So at every point, what you can store, the largest bar, the largest bar graph, you can think this as a bar graph, right? So where this is one bar, this is one bar, this is one bar, something like this. So for every, taking every row as the base, you can try to create a bar graph, and you can store the value of the highest bar in it. So let's say this has value 1, this has value 2, this is 3, this is 4, this is 5. So it shows that at a particular cell, so only having this cell will tell us that there is a bar graph of height 5 in it. Okay, that's what you can easily store it in this way. uh 5, 1, 2, and let's say we have a 4 here and we have a 3 over here. So 1, 2, 3, 4, 5, you see we have everything. Okay, so if you right now see, this will be giving you the largest rectangle because 3 into 2 6. Okay, but you see, you cannot club this for 5 and 4 anyway, because there are zeros in between. So what you can do, so if you think of this row, okay, if you just think of this row only for now, particular row I, you see that you have some elements which are arranged like this. Okay, and uh, what if you want to have the largest values together. So if you want to have something like this, 5, 4, 3, 2, 1, why would you want to have this? Because you want the largest area, right? So this is having an height of 5, this is 4, this is 3, this is 2, this is 1. Okay. So you would want to have the largest matrix. So you see, if you take only this row, the largest is nothing but height 5, 5 into 1. Okay. Now if you take this row and this two columns, okay, all the rows and two columns, then height of 4 into 2, you have 4 into 2. This was giving you 5, this was giving you 8. So you have a better option now. Okay. And this again had the height of 3 and the width of 3 also, right? So you get 3 into 3 over here, which is 9. Then again you have 2 into 4, which is again 8. Again you have 1 into 5, right? So I hope you do understand what I'm trying to do. I am trying to iterate through every of these rows. Okay, each row I am just storing the values by the bar graph, and I will try to reverse sort that row and try to take every width together. So first I will take width 1, secondly then I will take width 2, third I will take width 3, fourth I will take width 4. Okay, and so on and so on. I will just keep checking that. If I take this particular width, what is the largest rectangle? What is the largest rectangle that I can inscribe, taking that as the width? Okay, taking that at the as the width. So I checked for, essentially I checked for all possible width. All possible width. Okay. This thing I actually checked by reverse sorting them and doing that. So I hope the approach is now very clear to you. How will you look to solve this question? So yeah, let's do it. So we have int m, which is nothing but matrix dot size, which is nothing but the number of rows. We also have the number of columns as matrix of 0 dot size. And yeah, we want to iterate. So first of all, we want to fill these rows. Okay, we want to fill this 1, 2, 3, 4, something like that. This will be 2, this will be 3, this will be 2, something like this. We want to fill it again, this will be 2. So see, this thing which I told for one particular row, we will do this for all the rows. Okay, for all the rows, and take the whatever is the global max. Okay, so before that, first let's have the values arranged. Okay, so I will start with I equals to 1, because the first row is already written, will always be already written. We do not need to modify anything. From the second row, we will just check. So we'll start with the second row, and j less than n, j plus plus. So what exactly are we going to check? You will see that if matrix of ij is 1 over here, then I want to update its value uh, to what? I want to update its value to something like this, matrix of I minus 1j plus 1. Okay, so whatever value will be there before this. So if it's I see that here is a 1 present here, so I will add 1 to the previous element. 3 plus 1, 4. Okay, that is what I will do. And if it was 0, that will remain 1 as it is. 0 plus 1 is 1 anyway. So yeah, I do have this. And by just doing this, I have the matrix ready. I will have a maximum variable and try to return that variable. But yeah, I will definitely update it. So now I will go through all the rows and all the columns. Okay, because now I want to update my maximum. By taking each row, I want to reverse sort the row. Okay, so sort, I hope you know how to reverse sort it. Sort matrix of I dot r begin and matrix of I dot r end. So you reverse sorted this matrix, and yeah, as you are traversing through it, you will have access to the elements in a reverse sorted manner. So what does sorting or reverse sorting actually do? It brings the larger number together, right? So we want to have the larger numbers together. to have the largest area. It's quite obvious and intuitive. So uh, we do the sorting. That's why we do the sorting. So let's see what we will update to the maximum. Maximum will be nothing but max of this, and we want to multiply by this. So if uh, we have a height of size 4 and 5, so this gives this, let's say this 4 lies in index number 1, because 5 is the first index, right? So index number 1, but the width is 2. So index number plus 1 is the width, and what is the height? The height is the value at that row only. So into matrix Ij. So matrix Ij into j plus 1 is the thing, which is the area of the rectangle. Okay, so matrix Ij into j plus 1. We will just do this, and that's all. That's all with this problem. Uh, yeah, it was as simple as this, the implementation. Let's see if we have committed any error. So our solution looks fine only. Let's try to submit it for all cases and check. So yeah, we do have not very good runtime complexity, but yeah, this is an acceptable solution. Memory is decent, but yeah, if you got any better method than this, definitely try to share with me, because yeah, that is all I think, because m into n is 1e5 and I'm solving in m into n only. Just that I am doing a sorting kind of thing over here. Uh, which is helping me to efficiently bring the larger values together and find the largest area of the submatrix possible. So yeah, that's all. That's all for this video. If you have any doubt, definitely ask me in the comment section. And yeah, I will meet you in the next video. Till then, thanks a lot.